friends, I just wanted to come on and do a little video to introduce the chapter on conic sections. I think conic sections are so fun, and I hope you will too. There's a lot of graphing in this chapter. There's a lot of concepts that carry over between the different shapes, and it's just really interesting and fun, I feel like. Okay, so conic sections are a description of different kinds of quadratic equations that model cuts of a cone, of two cones, nose to nose. So you take two cones and you put them nose to nose, and then all the different ways that you cut them, you could cut it, produces different shapes, and each of those shapes is called a conic section. Think of like cross section as like the shape you get when you cut something. And so a conic section is the shape you get when you cut a cone. So for example, if you cut the cone straight across parallel to the base, you end up with this shape, which if you looked at it head on would be a circle. Okay. If you cut it at a tilt, but across, you would get something that looks like an oval, but what we call it, with a technical name for it, is an ellipse. If you cut up and down so that you hit both sides at the same time, you end up with something called a hyperbola, and it looks like this. It's got two different parts. One part that you would get from cutting the top part and one part from the bottom. This is a hyperbola. And then if you cut it parallel to this line so that it will go into the cone but it won't hit the top, that is actually a parabola. Now, you've already learned about parabolas in chapter 6, but the kind of parabolas that you've talked about have been functions. So you've talked about parabolas that open up or open down, okay? But for conic sections, we're going to also introduce parabolas that open side to side. So this chapter is going to be a study of all of the different kinds of equations that produce these shapes. You might wonder, what's the big deal? Why are we even talking about these shapes? Well, these shapes occur in nature all the time. And you will see circles naturally. That's not hard to convince people of. You see circles if you drop a pebble in a pond, and the rings of water come out in circles. If there's an explosion of some kind, the blast radius will be a circle. Any kind of like radio transmission, there's a radius, it's a circle. So that's easy to consider. An ellipse, the most common application for an ellipse is talking about the orbits of planets. Planets go around the sun, but they're not always the same distance from the sun. So like, if the sun is right here in the middle, sometimes Earth is further away and sometimes it's closer. The path the Earth travels is an ellipse. A parabola, there's a lot of applications for that. You've already seen them in the last chapter we did, but projectile motion, anytime you shoot something into the air, it goes up and it comes down. That's a parabolic motion. Fountains, there's a lot with acceleration, and so yeah, parabolas come up a lot. Hyperbolas, I think, are the hardest to really think about. They said there are some planets that have hyperbolic motion, like they come closer and closer and then they go back out, but they never come back again. So they're not an ellipse, but they kind of travel in this sort of a path. Also, so those are some of the different applications and just kind of an introduction to the shapes of conic sections.